two gigantic structures deep in the earth. Scientists have detected something strange and unusual, yet quite large, deep within the earth. These are two enormous structures that could constitute 3 to 9% of our planet's total volume. Scientists don't know exactly what these areas are or how they ended up deep within the earth, but they believe they may be remnants of an ancient planet. The structures are located beneath Africa and the Pacific Ocean, in the lowest part of the Earth's mantle, which is directly adjacent to our planet's outer core. The intriguing continent-sized structures lie at a depth of nearly 3,000 kilometers, almost halfway to the Earth's core. Scientists don't fully understand what these structures might be, and there's no direct way to find out. The deepest borehole ever dug by humanity is the so-called Kolar Super-Deep Borehole, which reaches 11,034 meters below sea level, with a total borehole length of 12,262 meters. Recently, Chinese engineers began work on a borehole 10 kilometers deep. That's quite a distance, but still a long way from the discovered structures. Scientists are left with the option of using seismic waves and their meticulous analysis. Two substantial structures could constitute 3 to 9% of our planet's total volume. Of course, we currently lack the technical means to examine them directly. Therefore, to learn more about these strange regions, scientists must resort to indirect methods. One extremely useful technique is seismic tomography. The association with earthquakes is perfectly valid here. When such tremors occur, seismic waves propagate in all directions. By examining them from several locations on the surface simultaneously, observing how they propagate, we can create a precise map of the Earth's interior. This is possible thanks to delays or distortions in seismic waves. The varying densities of materials within the Earth's interior affect the speed at which seismic waves travel through them, allowing us to study the planet's interior. Using seismic tomography, scientists were able to locate two unusual areas in the Earth's mantle. The method discussed above makes them easy to spot because seismic waves propagate much slower in these locations than in the surrounding space. The structure beneath Africa, dubbed Tuzo, is approximately 800 kilometers high, equivalent to 90 Mount Everests. The question arises, what are these regions? And unfortunately, science has yet to provide a definitive answer. The only thing we know about them is that their density is significantly greater than that of their surroundings, which suggests they may be composed of a completely different material. In our search for answers, however, we must be satisfied with theories for now. It's possible that these are nothing more than successive layers of oceanic crust, which accumulated in this area over billions of years as a result of subduction. Another idea is literally out of this world. It posits that it's Theia, or at least fragments of it. What is Theia? A hypothetical planet the size of Mars that collided with Earth some 4.5 billion years ago, and from its fragments the Moon was later formed. In 2021, a simulation was even conducted to determine whether fragments of this planet were present within Earth. It turned out to be possible. This idea had already been considered in research from 2 years ago.
Hummingbirds have easy access to alcohol. And they drink a lot of it. Under the right conditions, nectar-filled flowers can host fermentation processes. Researchers in California suggest that these flowers are an ideal habitat for yeasts and bacteria that metabolize sugar and produce alcohol. It turns out that hummingbirds take advantage of this benefit, sipping the liquid, which contains up to 1% alcohol. Alcohol, of course, isn't a human invention. It can be produced naturally in various ways. Therefore, animals can also come into contact with it. For example, hummingbirds can consume significant amounts of it daily, according to scientists from the University of California. But what effect does it have on them? The description and results of the research were published in the Royal Society Open Science Journal. We don't usually think about it, but if someone prepares water with added sugar for birds, they're potentially inviting them to a bar, as yeast or bacteria can nest in the water and initiate the fermentation process. However, such situations can also occur naturally. This applies to flowers filled with nectar. Yeasts and bacteria can also be present there, metabolizing sugar and producing ethanol. Birds that frequently use these water sources include small hummingbirds. However, this raises a number of questions. Above all, how do they react to the resulting alcohol? How much do they consume daily? And what effect does it have on their bodies? Hummingbirds consume food that accounts for approximately 80% of their body weight daily, and the source of this food is largely the nectar mentioned above. Therefore, even if only a small amount of alcohol were found in some of these sources, one would still expect the volume of alcohol consumed to be quite large relative to the hummingbird's body weight. Regarding hummingbirds' attitudes toward alcohol, researchers have observed that liquids with up to 1% alcohol content don't bother them. They readily sip on such water. However, they seem to be reluctant to overdo it with alcoholic beverages. A slightly stronger liquid, one with around 2% alcohol, begins to make a difference. In such a situation, they can still drink it, but only half as much as with a weaker solution. Although this effectively means they still consume the same amount of alcohol. Next, the researchers measured the alcohol content of the water in the dispenser for 2 weeks. It turned out to be even lower, a mere 0.05%. Still, consuming 80% of their body weight in food daily can still result in a significant amount. But the researchers suggest that these small birds likely metabolize and burn off alcohol quite quickly. They likely don't even experience any negative effects from its consumption. Simply put, they don't get drunk on it. However, there are animals that experience much stronger alcohol. A prime example are the shrews living in western Malaysia. They feed on the nectar of palm tree inflorescences, which can contain up to 3.8% alcohol. This also applies to the lapwing and the ii, a primate. Assuming, however, that our alcohol addiction is the result of evolutionary adaptation, we can conclude that a more thorough study of these mechanisms in animals will also contribute to a better understanding of them in humans. Extrasolar planet discovered orbiting 3 stars. In recent decades, astronomers have discovered thousands of extrasolar planets. Some orbit a single star, like Earth around the Sun. Some formed in binary systems, but now astronomers report the discovery of an exoplanet orbiting a triple star system. This very rare type of Jupiter-sized planet is located in the constellation Orion and orbits 3 stars simultaneously. Traces of an exoplanet were discovered in the triple star system GW Orionis, located about 1,300 light-years away in the constellation Orion. This system consists of 2 stars that orbit each other every 241 days, and a third star that orbits the other 2 every 11.5 years. The system is surrounded by a disk of gas and dust, typical of a young star system. This disk is divided into rings, which contain a rather puzzling gap. Detailed modeling of the system suggests that the best explanation for its existence is a large gas planet. The results of the latest observations were published in the journal Monthly Notices of the Royal Astronomical Society. GW Orionis is well known to astronomers. In 2020, the first study of this system was published in the astrophysical journal Letters. Astronomers took a closer look at GW Orionis using the Atacama Large Millimeter/Submillimeter Array ALMA telescope in Chile and discovered that the entire system is surrounded by a protoplanetary disk, a clumping mass from which planets form. This disk consists of 3 rings and has a gap between the innermost and middle rings. This gap is about 15 billion kilometers wide. Furthermore, the outer ring is tilted at an angle of about 38 degrees to the others. Scientists previously interpreted the observed gap as the result of the gravitational interactions of 3 stars. In the new work, astronomers use simulations to calculate the origin of the gap. They base their assumptions on observations of other dust rings elsewhere in the universe. The modeling results suggest that it was not the stars and their gravity that caused the mysterious gap, but rather a Jupiter-sized planet or several planets. We investigated a scenario in which a planet could be responsible for the gap in the disk. We compared our simulation with observations, and they match quite well, said Dr. Jeremy Smallwood of the University of Nevada, lead author of the paper. Scientists have previously discovered worlds that orbit one of the stars in a triple-star system, but they have never observed an exoplanet that orbits 3 stars simultaneously. However, the new findings will need to be confirmed, and as scientists point out, this won't be easy. The transit method, which has been used to discover most known exoplanets, won't work in this case. This method measures the brightness of stars to look for small, regular dimmings that could be caused by a planet's orbit around the star. If the planet's orbital plane is properly aligned with our line of sight, such a planet will periodically pass in front of its star, transiting, which causes a periodic dip in brightness. In this case, however, the orbital plane of the probable planet, or planets, is so aligned that the transit is impossible to detect, although this facilitated the detection of the protoplanetary disk. The best evidence for a planet or planets would come from high-resolution imaging of the system, although this is currently beyond the technological capabilities of our observatories, and the GW Orionis system is over 1,000 light-years away. Perhaps the James Webb Space Telescope, expected to launch this year, will be able to observe something. The authors of the new paper also note that 3 stars in the sky would be impossible to see from the surface of the probable planet. They point out that the 2 inner stars orbit so closely that they would appear as a single point in the sky.